Hello students, Miss Slyman here with some notes on variation. So variation connects in really nicely to algebraic fractions, and let's see why. So there's three types of variation: direct, inverse, and joint. Normally we look at variation in terms of two variables, y and x, and direct variation says that y changes directly as x, so there's some constant k and times x. So an example of direct variation is like y equals 2x. So for every x value, y is double the x value. Inverse variation is y equals k over x. So now, as x gets bigger, y gets bigger. As x gets bigger, y is getting smaller because I've got this constant k that gets divided by a bigger and bigger number. Joint variation pulls into play a third variable and says that y is equal to k times x times another variable z. So in this case, y is dependent on both x and z changing. So it will really depend that in this case, both x and z get bigger and y gets bigger. So in this situation, we would have to have two sort of sets of given constraints to be able to solve for our constant k. Whereas in direct or in inverse variation, we only need one set of conditions. So let's see what I'm talking about down here with example 1. If y varies directly as x, and maybe I should have left a little bit up here. If y varies directly as x and y equals 12 when x equals 3, find y when x is 16. So y varies directly as x. That tells me that y is equal to some constant times x. Y equals 12 when x equals -3. So straight away I can see my k value is -4. That means y is equal to -4x. So if x is 16, -4 times 16, the y value would be -64. So we're going to see in future examples how we'll get more of our rational expressions in here.